Hello and welcome to the Town of the Blue Mountains Drainage Master Plan Public Meeting Presentation for Public Information Center 2. This presentation forms the required public consultation as part of Phase 2 of the Municipal Class Environmental Assessment process for the Town of the Blue Mountains Drainage Master Plan. The public will be provided an opportunity to ask questions and express their concerns during virtual and in-person public meeting question and answer sessions described later in this presentation. Also, the public is encouraged to provide their comments and concerns regarding this project as described later in this presentation. My name is John Gore, and I'm a member of the Water Resources team at Tatham Engineering Limited. Tatham Engineering has been retained by the Town of the Blue Mountains to undertake the Drainage Master Plan, following Approach 2 of the Master Planning process, outlined in the Municipal Engineers Association Municipal Class Environmental Assessment document. This Drainage Master Plan is a broad-level assessment detailing the drainage deficiencies identified in the study area. It considers improvement options to address these deficiencies and the evaluation of these alternative solutions to assist in the selection of preferred alternative solutions to be implemented moving forward. Daniel Twigger is the project manager for this project and the manager of Water Resources Engineering at Tatham Engineering. Daniel can be reached at dtwigger@tathameng.com or via telephone at 705-444-2565, extension 2090. The problem statement for the Drainage Master Plan EA is as follows. Identify drainage deficiencies and recommend solutions to improve the storm drainage systems across the Town of the Blue Mountains in consideration of impacts to the natural, social, physical, cultural, and economic environments. The overall project team responsible for the Drainage Master Plan is the Town of the Blue Mountains, Tatham Engineering Limited, Grey Sauble Conservation Authority, Nottawasaga Valley Conservation Authority, Burke's Natural Heritage Consultants, Water's Edge Environmental Solutions Team, and ArchaeoWorks. Tatham Engineering is the prime consultant involved in the Drainage Master Plan and will complete the civil engineering components of the project. Burke's Natural Heritage Consultants has completed an environmental impact study assessing the natural heritage features in the study area. Water's Edge Environmental Solutions Team has conducted an erosion threshold assessment to assess the impacts of the alternative solutions being considered on erosion in the watercourses in the study area. Finally, ArchaeoWorks has conducted a Stage 1 archaeological assessment identifying areas of potential archaeological resources in the study area and the need for Stage 2 archaeological assessments as part of the detailed design for each alternative solution considered. The study area includes areas under the jurisdiction of the Grey Sauble Conservation Authority and the Nottawasaga Valley Conservation Authority. As such, the GSCA and NVCA are commenting agencies for this environmental assessment. The GSCA and NVCA are being consulted throughout the EA process to ensure their comments and concerns are being addressed. Existing drainage system analysis and deficiency identification, Phase 1 of the Municipal Class Environmental Assessment. This Drainage Master Plan is focused on developing drainage solutions for the settlement areas of the Town of the Blue Mountains, including Laura Bay, Thornbury, Clarksburg, Craigleith, Camperdown, and the Blue Mountains Village area. The study area covers settlement areas from Christie Beach Road in the west to Grey Road 21 or Osler Bluff Road in the east. Georgian Bay forms the north study boundary, and the settlement area boundary generally forms the study's south limit. What is a Municipal Class Environmental Assessment? A Municipal Class Environmental Assessment is a planning and design process to identify, compare, and evaluate alternative solutions to an identified problem. It applies to all municipal road, water, and wastewater projects and significant private projects as per the Municipal Engineer Association Municipal Class Environmental Assessment document. It ensures all aspects of the environment, physical, natural, social, cultural, and economic, are considered in the evaluation and selection of the preferred solution to be implemented. This EA is being conducted following Approach 2 of the Municipal Class EA Master Planning process, which involves the preparation of a master plan document at the conclusion of Phases 1 and 2 of the Municipal Class EA process. As part of Approach 2, the level of investigation, consultation, and documentation are sufficient to fulfill the EA requirements of Schedule B projects. Phases 3 and 4 are not included in the scope of the Drainage Master Plan project. The Municipal Class EA document classifies projects undertaken by municipalities into schedules based on potential environmental impacts. Schedule A and A+ projects are pre-approved projects that generally involve normal or emergency operational and maintenance activities that usually have minimal environmental impacts. Schedule B projects generally include improvements or expansions of existing infrastructure having minor potential adverse environmental impacts that must fulfill Phases 1 and 2 of the Municipal Class EA process before proceeding to implementation. Schedule C projects include construction of new facilities or major expansions to existing infrastructure that have the potential for significant adverse environmental impacts. As such, Phase 1 through 4 of the Municipal Class EA process must be completed before the project proceeds to implementation. It is noted that works undertaken under the Drainage Act are exempt from the Ontario EA Act and as such are not required to follow the EA process. At the conclusion of this study, all Schedule A, A+, and B projects will be able to proceed to implementation, while any Schedule C projects would still be required to fulfill the requirements of Phases 3 and 4 of the Municipal Class EA process. This Drainage Master Plan is approaching the end of Phase 2, and this Public Information Center forms the public consultation identified at the end of Phase 2. Phase 1 of the Municipal Class EA involved the assessment of existing drainage systems across the town, which identified drainage deficiencies to be addressed via this Drainage Master Plan. To assess the existing drainage systems, a detailed review of background information and engineering drawings was completed and comprehensive models of the town drainage infrastructure were created. Models were created for both the minor and major drainage systems in the town. The minor drainage system consists of catch basins, storm sewers, drainage swales, and roadside ditches which collect and convey runoff produced by frequently occurring storms, defined by the town in their engineering standards as a 1 in 5 year return frequency design storm, or the largest storm that's expected to occur in a given 5-year period. The major drainage system consists of the roadway and overland flow routes, which convey storm runoff when the capacity of the minor system is exceeded, as well as the various watercourses and culvert crossings throughout the town. The major drainage systems are designed to prevent flooding during rare storms such as the 1 in 100 year return frequency design storm or the regional storm, typically once-in-a-lifetime storms. In simple terms, the minor drainage system prevents nuisance flooding and provides public convenience while using roads during smaller, more frequent storms, while the major drainage system conveys flows and prevents flooding during significantly less frequent storms. Before drainage from the developed areas discharges to an appropriate outlet, it may first drain to a stormwater management facility such as a wet pond or constructed wetland, a dry pond, or a low-impact development measure. Stormwater management facilities are typically designed to limit storm flows from a developed area to pre-development levels and to remove sediment and other pollutants from storm runoff prior to entering the natural drainage system downstream. Low-impact development measures can be classified into 3 categories: lot-level LIDs such as rain barrels, rain gardens, and soak-away pits, linear LIDs such as perforated pipe systems installed below storm sewers, and infiltration trenches installed below roadside ditches, and centralized LIDs such as bioretention facilities or other infiltration galleries. As mentioned, models were created for the minor and major drainage systems throughout the town in order to assess the existing drainage systems and identify deficiencies. The minor drainage system model includes primarily storm sewer systems throughout the town. The minor drainage system model was developed by reviewing the town's existing storm sewer database and additional background engineering drawings were required to fill the gaps in the database. For systems with no available background information, field investigations and topographic survey were completed to collect the information required for the model. An excerpt from the minor drainage system model software is shown on this slide. The major drainage system model includes the various watercourses throughout the town and their associated culvert crossings. The major drainage system model was developed using the 2019 LiDAR topographic information provided by the town and by reviewing the town's existing culvert database, and additional background engineering drawings were available to fill gaps in the database. For culvert crossings with no available background information, field investigations and topographic survey were completed to collect the information required for the model. An excerpt from the major drainage system model software is shown on this slide. For both the minor and major drainage system models, drainage catchments were delineated using the 2019 LiDAR topographic information provided by the town. Catchment land use information and parameters were determined by reviewing the latest aerial imagery of the town, the Grey County soils information, and the 2019 town LiDAR topographic information. The existing condition minor drainage system model consisted of 1,174 storm sewers and 1,138 maintenance holes. The town's storm sewer design criteria were used to identify deficiencies. Specifically, a section of storm sewer has been identified as deficient if the storm sewer surcharges to the roadway during the 1 in 5 year return frequency design storm. Under this scenario, the section of storm sewer has insufficient conveyance capacity and storm runoff backs up through the catch basins in the roadway to the road surface. The deficiencies assessment identified 256 storm sewer with design standard deficiencies, such as storm sewers smaller than and storm sewers with less slope than the minimum count standards were identified. Additionally, 150 storm sewer capacity deficiencies were identified. An example of the minor drainage system deficiency maps prepared as part of the existing conditions analysis is shown on this slide. The full set of the minor drainage system deficiency maps can be found online at the Drainage Master Plan project webpage on the town's website. The existing conditions major drainage system models consisted of 1,183 overland flow route sections, 38 watercourses, and 208 culvert crossings. Similar to the existing minor drainage system deficiencies, the townwide major drainage system model was used to identify culvert and bridge crossing and major overland flow route deficiencies throughout the study area. The town's major drainage system design flood frequency criteria were used to identify culvert and bridge deficiencies. Specifically, culverts and bridges on local, collector, and industrial roads are to convey the peak flows generated by the 1 in 25 year return frequency design storm without flow over the crown of the road or no road overtopping. Culverts and bridges on arterial roads are to convey the peak flow generated by the 1 in 100 year frequency design storm with no overtopping. It is noted several roads in the study area are owned and operated by the Ministry of Transportation. Culvert and bridge deficiencies on these roads have been identified using the design flood criteria of the MTO. Each crossing has also been assessed based on the depth and velocity of flow over the roadway produced by the regulatory storm, which is the greater of the 1 in 100 year return frequency design storm or the regional storm. The depth and velocity has been assessed to determine if the crossing is passable by vehicular traffic during the regulatory storm. The MCEA's safe access egress criteria, specifically a depth of ponding of less than 300 millimeters, a velocity less than 1.7 meters per second, or a depth velocity product less than 0.4 meters squared per second, has been used to assess whether a crossing is passable. The same criteria have been applied to major overland flow routes. The deficiencies assessment identified overland flow deficiencies at 28 locations and 134 culvert crossing deficiencies. An example of the major drainage system deficiency maps prepared as part of the existing conditions analysis is shown on this slide. The full set of major drainage system deficiency maps can be found online at the Drainage Master Plan project webpage on the town's website. The existing conditions major drainage system models were also used to create flood inundation maps for the 38 watercourses modeled across the town. These maps show the maximum modeled flood extents resulting from the greater of the 1 in 100 year return frequency design storm and the regional storm. The flood extents were determined to provide an up-to-date limit of flooding through the study area to identify impacted properties and assess the impacts the alternative solutions have on flooding. An example of the flood inundation maps prepared as part of the existing conditions analysis is shown on this slide. It's noted the flood inundation maps are not regulatory flood maps and do not define the regulatory floodplain for the modeled watercourses. The full set of flood inundation maps can be found online at the Drainage Master Plan project webpage on the town's website. To address the existing drainage deficiencies, the following preliminary improvement options were developed and presented at the Public Information Center 1 for public input. The do-nothing alternative involves maintaining existing conditions and was used as a baseline to evaluate the effectiveness of other solutions. It is noted that due to forecasted increases in rainfall intensity due to climate change, flooding and drainage issues in the town will worsen if no improvements are made. General recommendations include improving storm sewer, ditches, and culverts to satisfy town standards, relocating municipal infrastructure off private property and into municipal lands, installing minor drainage systems in underserviced or unserviced areas, and improving overland flow routes. Flow reduction and water quality improvements, including retrofitting existing stormwater management facilities and constructing new stormwater management facilities to improve water quality treatment and reduce peak flows. This alternative also includes implementing low-impact development measures such as rainwater harvesting, soak-away pits, and linear perforated pipe and infiltration systems to improve water quality treatment. And conveyance capacity improvements, including constructing trunk storm sewers, upsizing culverts and bridges, improving watercourses and channels, and improving or constructing new overland flow routes to reduce flooding and improve public safety. The existing drainage deficiencies identified across the town and the preliminary alternative solutions were presented at Public Information Center 1 in February 2022, and feedback was received from the public. 7 comment sheets and 13 email responses were received from a total of 20 respondents, some of whom also attended the PIC1 Q&A session. Additional drainage deficiencies were identified by the public and included in the Drainage Master Plan analysis. Of the public responses regarding the preliminary improvement options, 0% of respondents were in favor of the do-nothing alternative. 100% of the respondents were in favor of storm sewer improvements, 43% of respondents were in favor of flow reduction and water quality improvements, and 86% of respondents were in favor of conveyance capacity improvements. We appreciate the feedback received during PIC1 and thank those who participated. This feedback was reviewed and considered to update the existing conditions analysis and when assessing the alternative solutions and individual drainage projects described later in this presentation. Development, assessment, and evaluation of alternative solutions, Phase 2 of the Municipal Class Environmental Assessment. Improvement alternatives were developed based on the noted drainage deficiencies and the input received from the public during PIC1. The following improvement alternatives were considered to address the project problem statement and correct the noted drainage deficiencies. Alternative 1A, Do Nothing Minor Drainage Systems. Alternative 1B, Do Nothing Major Drainage Systems. Alternative 2A, Retrofit/New Stormwater Management Facilities for Quantity Control. Alternative 2B, Retrofit/New Stormwater Management Facilities for Quality Control. Alternative 2C, Expansion of Existing Floodplain Storage Areas. Alternative 2D, Lot Level Low Impact Development Measures. Alternative 2E, Linear Low Impact Development Measures. Alternative 2F, Centralized Low Impact Development Measures. Alternative 2G, Mechanical Treatment Devices. Alternative 3A, Minor Drainage System Improvements. Alternative 3B, Culvert/Watercourse Major Drainage System Improvements. Alternative 3C, trunk storm sewer / overland flow route major drainage system improvements. Alternative 3D, drainage outlet design, operation and maintenance. And alternative 3E, drainage infrastructure, operation and maintenance. A pre-screening exercise was completed for the improvement alternatives previously described to determine which alternatives would be eliminated from consideration, carried forward as a general recommendation of this report, or identified for assessment and evaluation on an individual project basis. The pre-screening exercise involved completing preliminary assessments of the feasibility and potential effectiveness of the proposed improvement alternatives. For example, for alternatives 2E and 3A, the comprehensive minor drainage system model was updated to reflect implementation of these alternatives on a town-wide scale, and preliminary model results were reviewed as part of the pre-screening assessment. The pre-screening assessment identified that improvement alternatives 2A, 2B, 2C, 3B, and 3C should be assessed and evaluated further on an individual project basis. Individual projects for alternatives 2A, 2B, 2C, 3B, and 3C were identified based on existing deficiencies, and options for each individual project were evaluated to determine the preliminary preferred solutions. Alternatives 1A, 1B, and 2F were eliminated from further assessment following the pre-screening exercise. The results of the screening exercise are summarized in the table shown. Alternatives 2D, 2E, 2G, 3A, 3D, and 3E were identified to be included in the preliminary preferred solution as general recommendations. A total of 117 individual drainage improvement projects were identified for alternatives 2A, 2B, 2C, 3B, and 3C, with multiple options being considered for some projects. Preliminary designs and cost estimates were completed for each project to assist with the project evaluations. Projects were evaluated with respect to their impact on the physical, natural, social, cultural, and economic environments. The evaluation of projects with respect to the physical environment considered projects' impacts to water quality, flooding, and erosion potential. For the economic environment, project capital costs and maintenance and life cycle costs were considered, as well as potential cost savings resulting from the project. For the social and cultural environment, impacts to private properties and disruptions due to construction, public safety impacts, and archaeological impacts were considered. And for the natural environment, impacts on the fisheries, natural heritage resources, and wildlife habitat were considered. Based on the severity of impacts to the 4 project environments, both positive and negative, a score was assigned to each alternative solution for each of the 4 project environments. The scores for all 4 project environments were then summed, and the final score was used to identify the option with the most positive impact across all project environments for inclusion in the preliminary preferred solution. Preliminary preferred solution. Following the screening of improvement alternatives as previously described, general recommendations were identified for inclusion in the preliminary preferred solution. These general recommendations generally consist of Schedule A or A+ projects and are pre-approved for implementation at the town's discretion, as deemed feasible, in conjunction with planned infrastructure renewal and road reconstruction projects as infrastructure reaches the end of its service life. The following general recommendations were selected for inclusion in the preliminary preferred solution. Minor drainage system improvements under Alternative 3A, including upsizing storm sewer to satisfy current design standards, relocating drainage infrastructure from private property to municipal lands, and improving areas current absent of minor drainage systems to include storm sewers or roadside ditches as part of future road reconstruction projects. Water quality improvements under Alternatives 2D, 2E, and 2G, including encouraging residents to implement lot-level, low-impact development measures, such as rain barrels and soakaway pits where feasible, implementing linear low-impact development measures such as perforated pipe systems and infiltration systems as part of future road reconstruction projects where local conditions are favorable, and installing mechanical stormwater treatment devices within the storm sewer network as part of future road reconstruction and infrastructure renewal projects. The town currently is updating their engineering standards to include additional design criteria for drainage outlets to Georgian Bay to improve outlet performance and help protect outlets from blockage and damage due to wave action. It is recommended the town also establish a formal procedure for the inspection, operation, and maintenance of town-owned drainage outlets and progressively purchase property or easements for drainage outlets where it is in the town's interest to do so. It is recommended the town formalize their procedures for inspection, operation, and maintenance of culvert crossings, inspection, operation, and maintenance of stormwater management facilities, inspection, operation, and maintenance of mechanical treatment devices throughout the town. The estimated costs to implement the general recommendations included in the preliminary preferred solution are summarized in the table shown. The estimated cost for alternative 2D, lot level low impact development measures, is $0, as it is not recommended that the town fund implementation of this alternative, but rather encourage residents to implement lot level measures on their own. The estimated cost for alternative 2E, linear low impact development measures, is $25,910,000, which assumes full implementation of linear LID measures on all eligible roads in the study area. In reality, each potential linear LID project must be evaluated at the detailed design stage of an infrastructure project to determine if site conditions permit implementation of linear LIDs. Therefore, this cost represents the maximum potential cost of water quality improvement alternatives which will not be realized. The estimated cost for alternative 2G, mechanical treatment devices, is $9,950,000, which assumes full implementation of mechanical treatment devices for all eligible storm sewer systems across the town which currently do not provide water quality treatment. Recognizing that there is overlap between alternatives 2E and 2G, the actual cost for the town to implement both of these alternatives will likely range between the costs presented for alternative 2E and alternative 2G if deemed feasible by the town. The estimated cost to implement alternative 3A is $8,250,000, which represents the difference in cost between improving storm sewers to satisfy town standards and replacing storm sewers at their existing sizes. The estimated cost to implement alternative 3D, drainage outlets design, operation, and maintenance is $60,000, which includes the cost of updating the town's engineering standards to include criteria for outlet design and the cost for 1 year of operation and maintenance. The total cost to implement the general recommendations included in the preliminary preferred solution will range between $18,260,000 and $34,220,000, depending on the scale of the implementation of alternatives 2E and 2G. The general recommendations are to be implemented at the discretion of the town as deemed feasible in conjunction with planned infrastructure renewal and road reconstruction projects, as infrastructure reaches the end of its service life. Therefore, it is noted that the full estimated cost presented in this table on this slide will not be realized. The individual drainage projects recommended as part of the preliminary preferred solution are illustrated on the preliminary preferred solution maps shown on the following slides. The preliminary preferred solution maps are available on the project webpage for viewing. Several different types of drainage projects were considered for implementation as individual drainage projects to resolve specific deficiencies identified through the existing conditions analysis. Retrofitting existing stormwater management facilities or constructing new stormwater management facilities for water quantity control was considered in accordance with Improvement Alternative 2A. Following the evaluation of this drainage project, it was not recommended to be included in the preliminary preferred solution. Retrofitting existing stormwater management facilities and constructing new stormwater management facilities for water quality control was considered in accordance with Improvement Alternative 2B. Under this alternative, 7 potential individual projects were considered, and following the individual project evaluation, retrofitting one existing stormwater management facility was recommended for inclusion in the preliminary preferred solution. Expanding existing floodplain storage areas upstream of culvert crossings to provide attenuation of flood peak flows was considered in accordance with Alternative 2C. Under this alternative, 5 potential floodplain expansion projects were considered, and following the individual project evaluation, none of the floodplain expansion projects were recommended for inclusion in the preliminary preferred solution. These projects would face additional challenges of potential environmental impacts and complying with the MNRF Floodplain Management Technical Guidelines. Although minor drainage system improvements under Alternative 3A are included in the general recommendations of this study, 2 critical projects involving the decommissioning and relocation of existing drainage infrastructure on private property were identified and included as individual projects. These 2 projects include decommissioning the existing historical Beaver River flume in Clarksburg and relocating the downstream storm sewer off private property into the municipal road allowance. Preliminary designs were completed for these 2 projects, and the individual project evaluation determined that both of these projects are recommended for inclusion in the preliminary preferred solution. Improvements to culvert crossings and watercourses to improve the capacity of major drainage systems were considered in accordance with Alternative 3B. Under this alternative, 97 potential projects were considered, and following the individual project evaluation, 74 culvert and watercourse improvement projects were recommended for inclusion in the preliminary preferred solution. Constructing trunk storm sewers and improving overland flow routes was considered in accordance with Alternative 3C. Under this alternative, 5 trunk storm sewer projects were considered, and the individual project evaluation determined 2 of these projects were recommended for inclusion in the preliminary preferred solution. If you would like to speak to the representatives from Tatham Engineering or town staff regarding a specific drainage project shown on these maps, we encourage you to attend the virtual or in-person Q&A sessions discussed later in this presentation. This slide shows an example conceptual alternative solution plan for the recommended individual drainage projects number 21 and 22. These individual drainage projects include upgrading existing culvert crossings along a watercourse south of Thornbury known as Watercourse 52. These conceptual alternative solution plans provide a general improvement concept for the recommended projects, which will be further refined and expanded upon at the detailed design phase when a project is undertaken. Similar conceptual alternative solution plans have been prepared for all recommended individual drainage projects and are included in the 60% Drainage Master Plan report available on the project webpage for viewing. The number and types of individual drainage projects evaluated and recommended, and the estimated costs of the recommended projects are summarized on this slide. A total of 79 individual drainage projects were selected for inclusion in the preliminary preferred solution. Of these 79 projects, there is 1 stormwater management facility retrofit for quality control, 2 specific minor drainage system improvement projects, 74 culvert and watercourse major drainage system improvement projects, and 2 trunk storm sewer and overland flow route major drainage system improvement projects. The total cost of all the recommended individual drainage projects is estimated to be $87,453,000. However, some of the recommended drainage improvements fall under the responsibilities of the municipality of Meaford, Grey County, and the MTO. The estimated cost to implement the recommended drainage projects, which are the responsibility of the town of the Blue Mountains, is $56,815,000. Of this cost, we estimate $19,641,000 would be required to replace existing infrastructure at its current sizes, meaning the actual cost to the town to implement the recommended improvements is estimated to be $37,174,000. We note that this estimated cost assumes the drainage improvement projects will be constructed individually, while in reality there will be cost savings as some of the recommended drainage improvements can be completed during road reconstruction and infrastructure renewal projects. Additionally, the town is considering completing calibration of the Drainage Master Plan models to improve model accuracy. The current models are conservative and produce higher than anticipated peak flows, and we anticipate that model calibration will result in reduced peak flows, allowing for smaller infrastructure to be constructed at reduced costs to the town. In the Laura Bay development area, drainage improvements shown within the Boulder Channel Drainage Improvements area, outlined in yellow, were recommended as part of a site-specific study of the local drainage system. These improvements are currently being implemented by Laura Bay. If future drainage improvements are required for this area, they will be assessed and implemented by Laura Bay in accordance with site-specific studies in support of future development through the Master Development Agreement process. Drainage improvements shown within the Thornbury West Drainage Master Plan area, outlined in yellow, were recommended as part of the Thornbury West Drainage Master Plan Municipal Class EA completed by Tatham Engineering in 2019. The drainage improvements recommended by the 2019 Municipal Class EA were reviewed as part of this Drainage Master Plan and are recommended to be implemented as described in the 2019 Municipal Class EA. Some of these recommendations have been and are currently being implemented as part of the Thornbury West reconstruction project. There are drainage improvements recommended through a Drainage Act assessment completed by Crozier Consulting Engineers to resolve the existing drainage deficiencies and support proposed development in the Drainage Act study area. The Drainage Act assessment study area includes the downstream reaches of the watercourse 7 through 9 watersheds. A detailed study of this area has been completed by Crozier Consulting Engineers, which also identified existing drainage deficiencies in this area. The study completed by Crozier and the existing conditions analysis completed as part of this Drainage Master Plan determined watercourse 9 from Highway 26 to Georgian Bay and watercourse 7 from Highway 26 to Georgian Bay have insufficient capacity, resulting in extensive spills and flooding in this study area. There is an opportunity for drainage deficiencies in this area to be addressed as part of the proposed development in this area. As such, a petition for drainage works has been filed with the town in accordance with the Drainage Act. Conceptual designs of the drainage solutions proposed to be completed through the Drainage Act assessment have been prepared by Crozier Consulting Engineers and peer-reviewed by WT Infrastructure. WT Infrastructure has also reviewed the proposed drainage improvements and the process for the Drainage Act project to ensure the proper process is followed in accordance with a petition for the drainage works under the Drainage Act. The proposed drainage solution involves improvements to existing municipal drains. Watercourse 7 in the study area is the Blue Mountain outlet drain. Outlet 8 is the Blue Mountain diversion drain, and watercourse 9 in the study area is the Ford outlet drain. The proposed drainage solution includes the following works. An overflow channel will be constructed between the Georgian Trail and Lakeshore Road East to convey flow exceeding the capacity of watercourse 9 from watercourse 9 to outlet 8. An existing spill from watercourse 7 towards watercourse 6 will be eliminated, thereby incrementally improving flooding along watercourse 6, and an overflow channel will be constructed along watercourse 7 and Lakeshore Road to convey flow exceeding the capacity of watercourse 7 from watercourse 7 to outlet 8. The culverts crossing Georgian Trail and Highway 26 along outlet 8 will be improved to convey the additional flow directed to outlet 8 by the proposed overflow channels. As part of this Drainage Master Plan, Tatham also reviewed the drainage improvements proposed under the Drainage Act assessment and is in agreement with the proposed drainage improvement concept. We are in agreement that the sections of watercourse 9 and watercourse 7 downstream of Highway 26 do not have sufficient capacity, and therefore flow should be directed from these watercourses to outlet 8, which discharges across municipally owned lands to Georgian Bay, and can therefore be improved to convey the additional flow. As these proposed improvements are being undertaken through a Drainage Act process, they are exempt from the Ontario EA Act. Additionally, it is noted that modification of existing drains created through the Ontario Drainage Act is outside the scope of the Municipal Engineers Association Class EA. This slide provides an overview of the previous actions taken to date for the works proposed under the Drainage Act. On August 11, 2021, Council received the staff report regarding request for Drainage Act improvements to the Blue Mountain Outlet and Diversion Drain and the Ford Outlet Drain, and the clerk sent notification to the GSCA, and Council authorized staff to enter into agreement with the proponents to obtain funds to appoint an engineer under Section 8 of the Drainage Act to prepare a report, and that this appointment be effective 30 days after mailing the notice to the GSCA. On June 21, 2022, Council received the staff report regarding Regional Stormwater Management Plan Drainage Act Assessment Report, and that Council authorized staff to distribute the Drainage Act report to the MTO and the GSCA for review and approval. Upon MTO and GSCA approval of the Drainage Act report, Council authorized staff to bring the Drainage Act report back to Council for further consideration. On September 27, 2022, Council received the staff report regarding Regional Stormwater Management Plan Drainage Act Assessment, other agency approvals, and draft bylaw, and Council adopted the report by provisional bylaw on October 11, 2022, with the enactment of the bylaw being considered at the November 1, 2022 Committee of the Whole and November 14, 2022 Council meetings. On November 14, 2022, Council directed staff to broaden the consultation regarding the Regional Stormwater Management Plan Drainage Act Assessment to properties within the watershed of watercourses number 6, 7, 8, 9, and 10, and report back to the Committee of the Whole with the comments received. On February 21, 2023 and March 6, 2023, Town staff advised Council that following consultation with a recognized Drainage Act expert, it had been discovered that the requested additional consultation is outside the scope of the Drainage Act, and that to ensure the subsequent steps in the process are aligned with the legislated requirements of the Drainage Act, asked Council to instruct the clerk to send out notices of the Court of Revision. This slide provides an overview of the current status and next steps for the works proposed under the Drainage Act. The consultation required by the Drainage Act petition, barring any reassessment of costs at the Court of Revision, has been concluded. Public consultation is being completed as part of this PIC to both gain additional input from the landowners assessed as part of the current petition, as well as gauge resident interest in the town utilizing the Drainage Act to implement drainage improvements on Watercourse 6 and/or Watercourse 10. Although there was an opportunity for landowners within Watershed 6 and 10 to add their names to the developer's current petition, this PIC provides an additional opportunity to assess the appetite to undertake additional works under the Drainage Act. Town staff will be available to answer questions and receive comments regarding the works proposed under the Drainage Act at the virtual and in-person Q&A sessions. Written comments can also be submitted to Brian Worsley at the address shown at the bottom of this slide. Q&A sessions, comments, and next steps. Both virtual and in-person public meeting question and answer sessions will be held to allow participants to ask questions and provide comments regarding this drainage master plan. The virtual public meeting Q&A sessions will be held Wednesday, March 29th from 5 to 7 p.m. and the in-person Q&A session will be held at Town Hall on March 30th from 5 to 7 p.m. The virtual public meeting Q&A session will be held using Microsoft Teams, which allows participants to join by computer, mobile app, or phone. You must register with the Town of the Blue Mountains if you wish to attend the virtual public meeting Q&A session. To register, visit the project webpage on the town's website or email Kevin Burkint, Senior Infrastructure Capital Project Manager for the Town of the Blue Mountains at icpc@thebluemountains.ca. Registration for the virtual public meeting Q&A session will close at 4 p.m. or 1 hour prior to the start of the meeting. Upon registering the virtual public meeting Q&A session, details allowing each participant to connect to the session will be provided. Registration is not required for the in-person Q&A session, and all are welcome to attend. We encourage everyone to provide their comments and concerns regarding this project. The comments will be used to refine the evaluation and selection of the preferred alternative solution for implementation. Written comments may be submitted to Daniel Twigger, Manager of Water Resources Engineering at Tatham Engineering Limited, and/or Kevin Verkint, the Senior Infrastructure Capital Project Coordinator at the Town of the Blue Mountains, at the email addresses provided, or by completing the comment sheet available on the project website. Alternatively, you may contact Daniel or Kevin via telephone to arrange a time to drop off a hard copy of the completed comment sheet. Comments and information regarding this project are being collected to ensure a comprehensive approach to the study. These comments will be recorded for reference throughout the project, and with the exception of personal information, may be used in the final project documentation and will become part of the public record. Personal information provided is collected under the authority of the Environmental Assessment Act, Chapter E18, Section 7, and will be used in the development of the Master Drainage Plan. Questions about this collection of information should be directed to Kevin Verkint, the Senior Infrastructure Capital Project Coordinator, by calling 519-599-3131, extension 304, or emailing icpc@thebluemountains.ca. The Town of the Blue Mountains continues to enhance accessibility that is inclusive of all ages and abilities. The information provided at today's Public Information Center can be provided in alternative formats upon request. Such a request should be submitted to Kevin Verkint, the Senior Infrastructure Capital Project Coordinator, by calling 519-599-3131, extension 304, or emailing icpc@thebluemountains.ca. This presentation is a virtual format of the Public Information Center. Comments and concerns from the public regarding this project are welcomed and are to be submitted by March 31st, 2023. We ask everyone to provide their comments and concerns by this date. After this date, we will review and address all comments received from the public, agencies, and interested stakeholders. The alternatives evaluation will be refined based on the comments and concerns received, and the preferred alternative solutions will be selected. After the preferred solution has been selected, an implementation plan will be prepared to prioritize the recommended projects. We will also prepare development and policy framework to help guide the town's approach to development approvals and stormwater management in the future. This framework will also include recommendations on the use of the Drainage Master Plan models and updates to these models as part of future EA updates to reflect items such as climate change, future development, and the results of a potential monitoring and calibration program. Following this, the Class EA report will be finalized and reviewed by Council before being placed on the public record for a 30-day review period. To develop the implementation plan for the Drainage Master Plan, all recommended individual drainage projects will be evaluated in order of importance through an impact and risk assessment, which will consider factors such as infrastructure age and condition, severity of the existing drainage deficiencies, probability of failure, and economic, social, and environmental risks. Projects will then be prioritized based on the impact and risk assessment, as well as in consideration of the town's current capital plan to align drainage projects with other planned infrastructure improvement and replacement projects. As part of the implementation plan, we will also complete a funding review to identify potential sources of funding for drainage projects. A development framework will be prepared to provide a recommended stormwater management approvals process for new developments in the town. Recommendations will be included in the development framework involving the use of the Drainage Master Plan models in future development applications to ensure impacts from development are being managed at the watershed scale. A policy framework, including recommendations for stormwater management in designated future growth areas, will be developed for incorporation into the town's official plan. As part of this task, we will review and evaluate existing design criteria, drainage deficiencies, source water protection requirements, proposed land uses, redevelopment and intensification, and current policies. After reviewing the available information and this presentation, please register for the virtual public meeting Q&A session or attend the in-person Q&A session if you have further questions or concerns. Also, please submit a comment sheet with your questions and concerns and notify the town if you wish to be kept informed of the staff recommendation regarding the preferred alternative solution. As mentioned, selection of the preferred alternative solution will be refined based on the comments and concerns received during this Public Information Center. We encourage everyone to participate in the virtual public meeting Q&A session scheduled for March 29th, 2023, and the in-person public meeting Q&A session scheduled March 30th, 2023, and encourage everyone to submit their comments and concerns. If you have any questions regarding this study, please contact the Town of the Blue Mountains or Tatham Engineering at the addresses provided in this presentation. We would like to thank you for viewing this presentation and participating in the Town of the Blue Mountains Master Drainage Plan. This concludes the public meeting.